Okay. Right. So first of all, welcome everyone. So this is week 9 of HIT137 software now, and in this week we'll start working with computer vision. That is another important aspect of our software development. Okay. So before I start, a couple of announcements. Thank you all who has submitted your assignments, and we'll try to mark your assignment and try to give you hopefully by the end of next week. Okay, so give us 2 weeks time, so that by that time we'll be able to give you assignments with the marking rubrics and everything. Okay, and then keep in mind that your third assignment is also due in couple of weeks. So everything is sorted, everything is there, and then we'll start with the final exam as well. Okay, so that is important thing. Next week I'll talk about your final exam as well. That is also important, and I really request all of you to come and participate, because there will be some what is it called? There will be some feedback session that will happen as well. So please do come and participate as well. And I'll also discuss about the final exam format and your assignment as well for the assignment 3. Okay, let's start the class. So before I start the class, I'd like to ask all the students over here, first of all, online student, offline, face-to-face students. So till week 8, whatever you have studied, have you understood so far? Is that okay? There, guys, how about you guys? Have you understood me so far? How about you guys? Very good?
I'm struggling with the class, understanding
Okay, I understood. That'll I'll do it. How about online students? Have you understood me so far? What I have done with my class? I mean, till week 8, what we have done so far? Okay, very good. That's good to know that actually you're understanding. And yes, there are definitely a couple of confusions. We'll do a bit of revision as well. So in week 12, we'll do some bit of revisions for you guys. But in that case, it's good that you guys are understanding the class, which is very, very important, and we'll keep on working. So this week will be based on computer vision, again, a sort of very important component. And then next week we'll have, I think, Pygame or software security, and then Pygame. Week 12 will be a revision week, so we'll not have anything in week 12. Nothing new lecture actually. Okay, let's start. So in this particular, let me open this thing. Right, now I can write. Okay, so I was talking about that this particular week is actually another very important week for us, because we'll be working on computer vision. So a computer vision is a very important field. After actually having high-end computers with high-end graphics systems, and then we are working with OpenAI and artificial intelligence model. So computer vision has become a very important domain for us to work on, because with the computer vision you can analyze images of any complex images. You can analyze medical images, you can analyze environmental images, you can analyze traffic images, any sort of images. You can look for objects in those images. Okay, you look for important markers on those images. Okay, so this is a very important tool for us to work with. So working with large images, large files, Python is quite strong in that one. And in this week, we'll be starting to look a basic understanding of the image processing as well, which is a very important tool for all of us. And it will also help you to build your own application when you're working with images, as well as text and all other sort of Kinter windows and interfaces. So it's a very important field. And I'll also say that one of my own research that I'm doing, because I work quite extensively using AI in health informatics. So I work with health data. So I work with CT scans, then X-rays, MRIs, okay, and then ultrasound images, and looking for different types of diseases in that images through computer vision technique. So I know the importance of this thing, because these images are the forefront of a physicians, of a medical doctors, because they look at the images and they look for important markers in those images for the diagnosis. Now, As you can see that we have a huge number of data that is coming up, and we don't have enough people actually to go through all those images. So there's always a demand for an automated system of diagnosing those images and come up with some definite conclusion. Okay, so that's why I work heavily in that area, working with machine learning models, with advanced image processing techniques, trying to understand the important markers in the images and then classify them. Okay. Now, first of all, when I'm talking about the images, especially in an image, I mean, whenever you see a picture is divided into a number of what? In a basic knowledge, you know, there's pixels, right? So each and every block is called a pixel for us, right? What actually a pixel is? A pixel is actually, it represents the color, or it represents the energy of that particular block in that image. So if I'm talking about that particular, this pixel, so this contains one particular intensity that signifies that image, right? So now this pixel is, because, so what actually image means? Image means it's actually a combination of, collection of all the pixels together to represent a one complete image. That is actually what actually image is, right? Usually the image are represented with numbers like 1 and 0, for example. If I'm talking about 1 and 0, that means it is pretty much a black and white image, right? 1 is white, 0 is black. So when you see any sort of black and white images, so there's actually a mix of 1 and 0, right? So when I represent any sort of images in this type of matrix like this, so you can see that these all ones are white over here, and these zeros are actually black over here. As you can see, these are black. So this is actually one fine representation of 1 and 0s for images. Now, if I continue further, I was talking about only 1 and 0, which is black and white, but you can also talk about a grayscale image. A grayscale image is actually another updated version of a black and white image. But in keeping in mind, in both the images, you have only one value, we have only one value. So that is actually how a grayscale or a black and white image is represented. In a black and white, we have 1 and 0 just to represent 1 as a white, 0 as a black. In grayscale images, you can have different shades of black and white, right? So black and white can be having a different shades. So you can see this is actually a grayscale images where actually have different shades of black and white. Sometimes the intensity of black is quite high. Sometimes the intensity of black is quite low, right? So for that, we have a different numbers, as you can see over here. We have different of numbers over here. So like, for example, 40, 254, 70. So this actually represents the color intensity of that particular grayscale image. Now it is something that we don't need to do because already the images are captured either by using your mobile phones or cameras or any sort of thing. And our duty is actually to understand the pixel distribution of those images, what are the pixel values of those images. And as you can see, so they have a combination of all different numbers in that images, but you can see that there's only one number for one pixel, right? So a grayscale image is actually, again, a combination of pixels, but pixels are not only 1 and 0. They can have different values, but there's only one pixel value for one pixel images. Clear, guys? Understood? Was that easy for you to clear? Clear?
Yes, sir.
Very nice. So if there is actually 1 and 0 or 254, 74, whatever grayscale images are there, I mean, so this actually represents our grayscale images, which is one type of image that we use. Now let's continue further, and I will talk about the RGB. You know actually what is RGB, right? Red, green, and blue, right? So it's actually a very important combination of RGB. Whatever TVs and everything that you see, these are all RGB devices, right? RGB cameras as well. What actually happens that in that case, one particular pixel of a colored image is represented by 3 different channels. One is R, G, and B. So by combination of this R, G, B, and B, which is red, green, and blue, you can create any sort of colors to that images. That is the beauty of R, G, and B, right? So a color pixel, a colorful image means that a pixel will have combination of 3 values. And this combination can be, it is at 8-bit. If you're looking for an 8-bit resolution, okay? So it will be something like 0 to 255, 0 to 255, and do also 0 to 50. 8-bit means combination is 2 to the power 8, which is 256, which is 0 to 255. So you can have a range of anything from 0 to 255 for R, for 02254G and 02254 blue. So you can have multiple combinations of that one as well. And in that way, you have a varied combination. And that's why everything looks so colorful and detailed in terms of colors of the images, right? So this is another important thing, that when I'm talking about RGB images, I'm talking about each and every individual pixel of the images that contains 3 channels over here. And these 3 channels are R, G, and B. And as you can see, these 3 channels, when they combine together with different spectrum, with different intensity of R, G, and B, they come up with this nice picture, which is real and which is actually validated, which is actually something, the real image or the trustworthy image that we can say. So this is called and RGB images, where each pixel contains 3 band of pixel values. Now let's continue further. Then you'll understand why actually we're using this type of thing. So in order to process the image in Python, this is a very common tool and a very powerful tool, which is called OpenCV. OpenCV is actually a very powerful open source library that is used for image processing. Now, in OpenCV, you can easily read each and every individual pixel value of the images, and then can put it into a NumPy, which is called NumPy. So this is another type of library that we use in an array format. So it reads each and every pixel value, and it can create an array for us with combinations of ones and zeros for what is that called, for one grayscale or black and white images. On the other hand, with the RGB images, for one pixel, we have 3 channels, R, G, and B. In this way, we have multiple channels for 1 pixel. So you can have a combination of R, G, and B for 1 pixel. So in that way, OpenCV can also read RGB for each and every individual pixel using the colorful images as well. So our aim is not to actually, build the image based on color, because we have different cameras that can take the picture of the images. But our duty is actually to extract the pixel information of the images, so that you can use this pixel information to understand the different objects that are present in the images, because each and every individual object has got different shapes, different look, different color, different signatures, and those things can be easily identified based on the pixel information that you have in the images, right? So our aim is actually to analyze those images using that pixel values. So that is actually something that we are trying to do. Now, so for that, OpenCV is a very important, powerful library that can be used for processing all these images, and then we'll be working on OpenCVs in the coming slides. Now, there are some installations. Now, keeping in mind, we have already provided all the code for each and every individual problem that we have done. And this has been, we have been doing it from the week 1 itself. Every week, whatever I teach you, we provide the solutions for that every week as well. So it is there already. So you can see those code and you can practice those code as well. I think it's a good thing for us, but on the other hand, I also sometimes get worried that if you don't practice those things, then it'll be hard for you to address or to sit for the final exam. That is another important thing. So anyway, so this is called pip. Pip is actually called an installer that we install. This is a command. Pip command allows you to install any sort of library. So there are a number of libraries that I'm installing for the time being. Why I'm installing that thing, it will come to you in the coming slides. OpenCV Python, it is installed to work with the images. NumPy, it is installed to work with numbers of those pixel values. And matplotlib, it actually works with showing the images, converting the images, plotting those images in the plot file. Okay, so this is actually installed. Then after that, once I install all those libraries to my IDE, Python IDE, then we can import those libraries, which is called CV2. Then import matplotlib, pyplot as PLT. PLT is actually the plot thing. So these are some of the specific commands that you just don't need to, you can memorize or just copy it. These are actually all built-in commands. So CV2 actually uses for image processing, again with OpenCV. This matplotlib.pyplot actually is used for plotting all the sort of images, and importing NumPy as NP. NP is actually a handler that actually works with the numbers using NumPy as well. So these are all different types of import that we'd like to do once you have installed all the libraries. So these two things goes parallelly side by side. So once you finish installing, you call them as well, you import them as well. So this is actually the first thing. So these are the important things, initial important things that you need in order to work with image. First of all, you have to install the OpenCV Python, then you have to install the NumPy, and you have to install the matplotlib as well. And then you just import all of them one by one to use them to your Python IDE. That is actually how it works. So it's a pretty straightforward import and installation. Now let's go one at a time. So there are some codes that we have given, and all these codes are there as well for you to understand, and you can easily do that. Very simple, straightforward, but you have to understand. Now, first of all, what we have done, we have created an OpenCV library and have imported the CV2. So this is actually the OpenCV library that actually can be used to work with all the OpenCV methods that we have. I have imported the matplotlib as well. So I want to import that thing because I want to plot it. I also import NumPy because in the future I'm going to use the pixel numbers to play with the number as well. First thing that I have done, I have created a logo, which is called logo.jpg. So what I have done, if you see, this is actually a CDU logo, previous one, not the current one. Current one has changed. So what I have done, we went to CDU website, download this logo, and save it as .jpg, right? So this is a JPG file. You know what a JPG file, right? So this is actually pretty much a picture file that you use. So you install that thing. So what you have done, you have put that thing into your current directory, and then what I'm saying, I'm just calling that image with cv2.imread, which is called image read. What I'm going to read, logo.jpg. So it is this particular function will allow me to load the image and store the image into the image variable. So image is actually now the logo of that particular CDU. The logo of CDU actually, that which is the image it is containing. So it is just simply reading that image and storing that into the image variable. Then I'd like to show that image. So when I'm going to show that image, so same library, this is called reading, this is called showing. cv.imread means I'm reading the image, cv.imshow means I'm showing the image. Very simple, right? Image read, image show. So I'm saying cv2.image show, imshow. So this is going to show the image. So the first argument is called the window name. So for example, which the window, because it's going to be displayed in the window. So what is the name of the window? I'm saying CDU logo. And the next argument actually, what actually I want to display. So the image. So this is my CDU image. So this is actually the output that I'm looking for. So very easy to import an image and to show that image to a specific window. OpenCV is very, very strong in that way. And you can easily use that type of thing to build any sort of app while you're working with images. Okay, you load, you install, you display, everything that you can do. Then what I'm saying, CV2, this is again the library that I'm using, CV2.waitKey. So this is actually object and a method. WaitKey is I'm going to wait it until, and then I put 0. So this is another instruction. So it will hold the image until you cross it or until you close the window. So in that way, what will happen? This will show me this particular image, and we didn't show you the but they'll be called CDU logo over here as a window name. So this is an image that has been already been read from your current directory and displayed using cv2.image_show. Now this itself is very easy for us to do, because for our application development, we are not actually doing a lot of image processing. We are trying to do, because we are not actually in the field of image processing right now, but what we are trying to do over here as a part of application development, we'd like to load the image, show the image, okay, print the image, put the image on a specific size, on a specific format, on a specific location. All these things, these are the basic commands that can be used to do that. So this is one of the way of just using OpenCV library and then loading an image and plotting an image, right? Clear, guys? Understood this, right? Clear? How about you guys? Have you understood? How about you guys? Clear? Very nice. Online students, have you understood so far what I have said? Let me see my online students. Where are they? Is it clear? Good. So that means we have already understood a basic of image processing. I mean, image loading and image displaying. Now, let's start more. So Especially CV2 actually is a way of image show, and image read is actually a way of displaying image, but they are not very strong library comparing to matplotlib. Matplotlib itself is actually a separate package that actually they have advanced operations, they have an advanced way of plotting images. Okay, they can plot images in different dimensions, different colors, from 2D to 3D, 3D to 2D, also different types of things they can do with matplotlib. So these are an advanced packages that can be used in order to, and they can also do more granular image processing as well. So that's why we use OpenCV for reading the images, but we use matplotlib for displaying or plotting those images. So this is actually another one which is called matplotlib that we'll be using. And for example, I'm going to use, suppose over here, as you can see that this is actually colorful image, right? So it contains both black, white, blue, and all sort of colors are there. Now, in the matplotlib, what actually happens that whenever OpenCV reads the image, it reads in this format, which is called BRG, okay, which is called blue, red, and green. Now, but when I'm going to read it in a matplotlib, it should be converted. It needs to be converted to RGB because matplotlib works in RGB format. So this BRG, which is blue, red, and green. Sorry, it is BGR. Blue, green, and red should be converted to R, G, and B. So that means there should be some transposing. So we need to transpose from blue, green, and red from BGR to RGB for using matplotlib. How we have done that thing, as you can see over here, what we have done, we're going to use the matplotlib over here, but you can see that what I have done, we have said cv2.cvt color. So I'm going to convert the color. So I'm using the cvt is actually the library, OpenCV library. .cvt color means converting the color arrangement. Which one? Based on the image that I have already loaded over here. cv2.color underscore BGR, which is blue, green, red, to RGB, which is RGB. So red, green, and blue. This is actually one specific line that is used to convert image from BGR to an RGB. Again, just you need to know how to call this particular file. You need to memorize that thing. This particular one, which is called cv2.convert, it actually converts the image color from blue, green, red to red, green, and blue, and then that is actually stored into the plot. So this is something. Again, I'm using OpenCV to convert. Now this PLT is called matplotlib, as I have shown you over here. As you can see, when I have already called that one, which is called import matplotlib as PLT. So this PLT is actually a handler that is uses matplotlib actually to work on. So it will have all the functions of matplotlib as a handler. So what I am saying over here, I am saying PLT, which is called the handler, dot the method, which is image show. Again, I am show. Now this is not just cv2.image show. So I have changed the cv2. I'm using matplotlib, which is PLT. So PLT dot image show image, then PLT dot show. So it will actually show the image, or it will display the plot. So this particular PLT dot show, it will hold the image, it will hold the screen for some time unless you don't close it. Now same thing, this plot.image show is one, and in the last slide I have shown you cv2.image show, that is another one. But why I'm moving from cv2 to .plt? Because cv2 is actually OpenCV images, OpenCV libraries. They have less functionality comparing to matplotlib. So that's why I'm using matplotlib. I'm importing matplotlib as PLT. So PLT is handling all the matplotlib methods. So I'm using PLT for that. So same thing, plt.image show. But in order to, as I mentioned, in order to work with PLT or matplotlib, you have to convert your image from BGR to RGB. So this is the only line that you have to put in first for the conversion. Once you have converted, you can use definitely the matplotlib, and then you can display the image, image show with the image, and then you just say plt.show. That means you're holding the screen, and you can see we got already a particular image of the whole matplotlib. Now, there is nothing new that you have learned over here, but there's one transition that you have done. Now we are not using cv2.image or not using OpenCV cv2 libraries. We are using matplotlib libraries actually for our display, for our plots. Now let's continue further, then it will be much more easier for us. Even I can also find out what is the height and the width of the image. So the image that we have displayed right now, what is the height and the width of the image you'd like to see. So what I'm saying, H and W which are the two variables that you know, so height and width. Now if you don't know, I mean you should, because these are basic things that you learned already. So I'm saying get the shape of the image. So the image is the CDU logo that I have already installed. And then I'm putting a slicing 2, that means by default 0 to 1. So that means height and width, right? Slicing 2 means what? 0 to 1. So height is 0 and 1 is width. And then saying print height H, print width W, it will give me the height of 256 and 256. So you know what is 256? Tell me what is 256? What is basic knowledge? What is 256 over here? What do you think? I mean, I think this is something very, because you have been playing with all cameras, pixel camera, high resolution cameras and everything. So you don't know what is 256 by 256. Do you know 1024 by 1024 image? What is the resolution? So what is this unit called? Huh? Pixels, right? So 256 is pixel. So you guys are so computer techie and then all sort of iPhone techies. You know, you work with the cameras and the quality of the images and everything. So it is important for us to know what actually these are units are. So this 256 is what? This is called the number of 256 pixels on the height and the number of 256 pixels on the width. So this is actually a range of matrix of 256 times 256. That means I have 256 pixels on the row and have 256 pixels on the column. And in that 256 by 256, I am just resolving. So that means my image size is not that big, right? So 256 by 256, then 512 by 512, then 1024 by 1024. The higher the pixel, the bigger the image is. Yes or no? The higher the pixel, because your height gets high and your width also gets high. Simple concept, right? Now these are very basic things that we should understand because these are very basic components of the images as well. Okay, so they're saying that this is actually a particularly 256 by 256 image size. So number of pixels on row and column are all 256. Okay, let me get a new recording and then I'll start.